Welcome to The Explainer. We're all about breaking down really big topics into something you can actually wrap your head around. And today, we're tackling something we all use every single day. But how many of us really know how it works? Yep, we're talking about the internet.
So think about it. You type in a website, hit enter, and poof, a whole world just appears on your screen. It feels like straight up magic, right? Well, today we're going to be the magicians, pulling back the curtain. We're going to follow that single click on its incredible, super fast journey across the entire planet and back again. Let's get into it.
All right, so our journey starts the second you ask for that website. And it's not like you're just yelling into some digital abyss and hoping for the best. Nope. There's a really specific, really fundamental model for how all of this communication happens. It's kind of the bedrock of the whole internet. Let's stick with a simple analogy here. Think about ordering a pizza. Your web browser, that's the client. You're the hungry customer. You're the one kicking this whole thing off by making an order. And the website itself? Well, that lives on a server. Just think of it as a super powerful computer at the pizza place, always on, just waiting for your call so it can send out that pizza. Okay, but before your browser can even place that pizza order, it needs the right address. See, we humans like easy names, right? Like, theexplainer.com. But the internet, it works with numbers. So to connect those two worlds, your browser has to look up the address in what's called the domain name system, or DNS. And honestly, that's the perfect name for it. It's literally the internet's giant address book. Its one job is to take that name you typed and find the real numerical IP address for the server.
So now we have the server's numerical address. We're good to go, right? Well, not quite. You can't just send your entire request as one giant blob of data. That would be like trying to stuff a whole car into a mailbox. It's just not going to work. Instead, the internet has to get clever. It has to break everything down into smaller, much more manageable pieces.
And this whole process has a name. It's called packet switching. Basically, your request and all the website data that's going to come back to you gets chopped up into these little blocks of data called packets. The best way to think about them? Digital postcards. Seriously, each little postcard gets its own address label, and then it's sent off to make its own way across the internet.
But wait a second. If you're sending out all these separate postcards, how do you make sure none of them get lost in the mail? Great question. That's where this little digital conversation comes in. It's called the TCP handshake, and it's like a polite three-step greeting. First, your computer, the client, sends a message saying, "Hey, can we talk?" That's the SYN packet. The server writes back, "Yep, sure can. I hear you." That's the SYN ACK. And finally, your computer says, "Okay, great, let's talk." That's the final ACK. It's this ready, set, go that makes sure the line is clear and reliable before any of the important stuff gets sent.
And that right there, that's really the secret sauce of the entire internet. It's not just one big invention. It's a whole bunch of different rules, we call them protocols, that were all designed from the ground up to work together. They're a team. Each one has its own little job, and when you put them all together, you get this incredibly powerful and, honestly, super resilient system. Okay, so let's recap. Our digital postcards are all packaged up, they've got addresses on them, they're ready to go. But how in the world do they find their way? I mean, the internet is this mind-bogglingly huge web of connections. How does each little postcard know which way to turn to get to the right server? Well, that's where that IP address we found earlier comes into play. That string of numbers, that's the exact mailing address for our server. There's no confusion, no ambiguity. Just like a street address points to one specific house on a map, that IP address points to one and only one computer on the entire global internet.
So who's guiding these postcards on their journey? Devices called routers. And you probably have one in your house right now. Think of a router as a traffic cop, or maybe an employee at a mail sorting facility. It doesn't need to know the entire map of the world. All it does is look at the address on a packet and make one simple decision. Okay, where do I send this next to get it just one step closer to where it's going? And how does it make that decision so blindingly fast? It uses something called a forwarding table, kind of like the one you see here.
When a postcard, or a packet, arrives, the router just looks at the destination address. It scans its table for the general area, finds the match, and boom, forwards it to the next stop, the next hop. It's so efficient. No single router has to hold a map of the entire internet. It just needs to know its own little neighborhood and where to send things next.
You know, up to this point, we've been talking about digital stuff, protocols, addresses, data. But now, the journey gets physical, like really physical. Those packets, our little postcards, actually have to travel across a massive global network made of real-world stuff. So if you're watching this from home or an office, chances are your request starts its journey as tiny electrical pulses zipping down some good old-fashioned copper wires. I'm talking about the same kind of twisted pair wiring that's been powering our telephone lines for, well, over 100 years. It's amazing that it's still part of this.
But to go long distance, like across countries and oceans, electricity isn't fast enough. So that electrical signal gets converted into pulses of light. And these little flashes of light travel through fiber optic cables, strands of glass so pure and so thin, they're thinner than a human hair. They literally bounce their way across the planet at pretty much the speed of light. This right here is the true backbone of the modern internet.
And then, of course, there's the very last leg of the trip. You know, for those last few feet from the router in your living room to the phone in your hand. The signal changes again, this time into radio waves that travel right through the air. And that, of course, is what we all know and love as Wi-Fi. And believe me, the type of physical connection you have makes a massive difference in speed. I mean, just look at this. Modern fiber optics, the ones using light, just absolutely blow the older technologies out of the water. They have so much more capacity, so much more speed than the old DSL lines or even a lot of cable connections. It's not even close. Now, this is pretty wild. For some people in really remote places, their data goes on an even crazier journey. Your little packet gets beamed, get this, over 22,000 miles straight up to a satellite and then all the way back down to Earth. That trip is so long that you can actually feel the delay. It's a tiny lag, but it's a real reminder of the incredible distances our data sometimes has to travel. So, after this epic journey across copper wires, through glass fibers, and over radio waves, our little postcard finally arrives. The server gets the message. It processes your request, grabs all the pieces of the website, the text, the pictures, the code, and then guess what? It packages it all up into new postcards and sends them right back to you, making that entire journey but in reverse. So let's just step back for a second and think about what we just saw. That whole ridiculously complex sequence, the address lookup, the digital handshake, sending postcards across a global network of wires and light, getting a response, all of that happens in less time than it takes you to blink. It's just staggering. And that system of cooperative rules, those protocols, it has turned out to be unbelievably strong and flexible. I mean, it was originally designed decades ago for just a handful of researchers, and yet it's scaled up to connect billions of us on every continent, adapting to every new piece of hardware and technology we've invented since. It's an incredible piece of engineering. So, the next time you hit enter and a web page just appears, you'll know what's happening. It's not magic. It's this beautiful, silent, and frankly miraculous journey. It's a fleet of digital postcards, guided by a symphony of rules all working in harmony. It's a system that doesn't just work, it's the foundation of our entire modern world. So the real question is, what are we going to build with it next?